everyone, and welcome to our webinar. My name is Olga Osipov, and I will be your moderator. I lead the marketing team at Anywhere Networks, and I am very excited to be hosting this session today. Today's conversation is about our products and what makes our networks intelligent. So I'm pleased to introduce our speakers, Bo Larson, Executive Chair and Chief Operating Officer at Anywhere Networks, and Marcus Holmberg, Director of International Sales. Well, just a few words about our presenters. Really wanted to give you some more information so you know who will be presenting today. Bo is the former CEO of FireTide. He's a recognized technology market leader who held major leadership roles as the GM and VP of Sony Corporation of America, Senior VP of Ericsson, and Corporate VP at Sony Ericsson. I think I missed probably a few more, but I think that will give you an idea. And also today, he's going to share with you our vision and our roadmap. Just a few words. Marcus Holmberg is our Director of Sales, and he has a remarkable international career that also began at FireTide. His technology expertise grew successfully when he developed a business for a variety of startup companies. Marcus is a dedicated and energetic professional with experience in high-tech sales, business development, and marketing. He will talk about our products, unique features, and intelligent networking capabilities. Before I hand over, the microphone to Bo, I have a few housekeeping items to cover. So this presentation and also the GoToMeeting webinar platform. Hopefully, most of you know how to use it. First, I guess today's webinar will be available on demand after the live session and accessible through our resource page on our website. Our webinar structure is pretty simple. First, we'll hear about our company, product, and solution features, and then we'll proceed with our Q&A session. Next, would love to hear from you during today's presentation. If you have questions while the speakers are still presenting, you can use our chat box and send your questions there. We'll try to answer all the questions, but if we don't get to your question during today's webinar, we'll be sure to follow up afterward. So, and at last, I'd like to encourage you to share today's webinar recording with your teams, your sales teams, and customers. So, without any further ado, I'd like to kick things off by welcoming our COO, Bo Larson. Bo, over to you.
Thank you, Olga. That introduction was too kind. And thank you for doing the webinar, by the way. So first of all, I want to say thank you for everybody that is joining the webinar. Really appreciate it very much, And I do know that I know many of you because I met you at ISC West. I know your names. So I met you at MIPS. So that's from my FireTide days. So I really appreciate that. And I'll tell you, I'm super excited to be back at this again and re-engage with the Annixter ecosystem. I was thinking about it like a few minutes ago when I signed the first distribution contract at FireTide globally, I think with Annixter like 2004. So that was 15 years ago. So I didn't want to go on video today, but here I am. But anyway, so that was a long, successful relationship, and I'm really looking forward to do it again. We have signed an agreement with Annixter, as you probably know, and Annixter have stock in-house. So and we are ready to launch the business in North America now. So I'm really excited about that part. What we are doing now, so let's forget about FireTide because now it's all about Anywhere Networks. And just so you know, you might have heard the name P2 Wireless. P2 Wireless has been around for a few years developing technology, setting up a technology center in the Bay Area here. And we also have established a regional office here in the Bay Area, headquartered in the Bay Area. The mothership is in the headquarters in Hong Kong, but what we are doing now is bigger and better than what we did at Firetide. So Marcus will tell you more about that. But basically what we are doing at Anywhere Networks is we provide network infrastructure solution for smart cities, connecting any IoT device in many locations. And we have the ability to carry a lot of capacity. We'll tell you more about that. But the immediate focus we have is safe cities, meaning connecting CCTV cameras, again, via an Ethernet cable into the network. And we are doing that because we have optimized the network infrastructure for video, just like we did at Firetide, but we are doing it better this time. So the solution we have is a secure infrastructure. It's very scalable. It has the ability to carry a lot of capacity, and it's based on an intelligent implementation of established and well-known network technology in the fixed environment. So we have already deployed, just so you know, in 15 countries with major global system integrators and mobile operators. So the technology is proven, deployed, and successfully installed in 15 countries. The markets that we are targeting is, of course, infrastructure where video is required. So smart city, safe city, industrial markets, I call them. They might not be the right word, but it is places like ports, airports, prisons, schools, mines, housing authorities, and places like that. And then, of course, later in the year, we're going to implement full mobility in this infrastructure that is expansive. And then we will go into transportation network markets as well. So I think with that, I just want to, again, say thank you for joining us. And I think at this time, I'll hand it over to Marcus.
All right. Thank you very much, Bo. As Olga and Bo mentioned, my name is Marcus Holmberg. I work with international sales, and I started my wireless career, so to say, at Firetide back in 2011, where I first started working with Bo. So we've been working together for a very long time, and I'm super excited to be working together again. Basically doing like Firetide 2.0. We started with Anywhere Networks, and we have now come with a very intelligent wireless network infrastructure solution that's scalable up to 19,200 locations to connect smart cameras, IoT devices around in cities. So basically, wherever you need network connectivity, Ethernet connectivity, you can place our nodes and connect. And I'll get more in detail into the technology in a little bit. I want to say that there are a few things that we improved, of course, since we have a lot of experience with Firetide. One of the things is the performance of the network. We can do up to a gigabit of performance, whereas we could only do 150 megabits with Firetide. We also made the network more cost efficient, easier to use, and we have no license fees on the network. So the whole network is more cost efficient, higher performance, and a completely new hardware generation. So we have a lot of good things here that I'm sure you'll like. We work with a business model, tier 2 business model, with Annixter as our distributor, and we also work with resellers, partnering with resellers for the projects. So we go to market with industry-leading partners, such as Access Communications, Milestone for the video management platform, ISS, Pivot3, and Quantum for the storage, and many others. And yeah, we partner with these technology companies for whenever they have any customers that need to have a wireless connectivity, where they don't have cabling infrastructure, or where it's too difficult to dig or too expensive. They recommend us, and we work with them on a global level. So there is a market opportunity, as I'm sure you're aware of, for smart city and safe city type of projects. We've seen that there's the government, transportation, and utility sector, including the industrial sector, amounts to over $342 billion by 2020. And this is the market we're targeting with immediate focus on safe city projects, because a lot of our bread and butter comes from connecting video surveillance cameras wirelessly back to central location for viewing. So the market requirements that we see is that there's a need to connect many devices, starting with cameras, but also to connect sensors, displays, Wi-Fi access points, including mobility for vehicles and so on. And in order to be able to connect all these devices, there needs to be, there cannot be cabling everywhere. It's just simply impossible. So you need to have a wireless extension from the existing cabled infrastructure, and that's where we come in. We provide one management solution for an entire network, as I mentioned, up to 19,200 locations, and that'll be scalable up to millions of locations, literally. So this is a huge network platform, and everything managed from one point, and or several points as well if needed. We also have the ability with our network to start small, so the customer can just start with a few nodes and then organically grow the network to complete a smart city or safe city implementation. The network has a very high level of security, as well as a low cost, little disruption, and a very, very rapid implementation. And I'll show you some examples and case studies of that as we go on in the presentation. Some of the main application areas are smart cities, public safety, rural premises, wireless backhaul, transportation, campus coverage, and many more types of applications.
Marcus, let me interrupt you. Yeah. Can you make it in presentation mode so we can hear a bigger screen?
I thought it was. Apologies. Is it now?
No, I still see the slides on the side.
Okay, then I'll just have to make it bigger.
Okay.
Maybe. Is that okay?
Yeah, that's better.
Sorry.
That's okay. That's better. Much better. Thank you.
Okay, great. Thank you for letting me know. So how we match these market requirements? Well, what we provide is an intelligent networking technology that allows a wireless network to work like an Ethernet switch. So let's say that you have an Ethernet MPLS switch at your headquarters, and the idea is that you take this switch, you can divide it up into pieces, like you see here, saw it up into smaller pieces, and then distribute these in the network to provide the Ethernet connectivity. So basically, our network works like a distributed or wireless Ethernet switch. So the entire network works like one Ethernet switch, which has a single IP address for centralized management, whereas other networks, they would have to have set up IP addresses for each node, whereas ours, it works like a single large switch. So this is a very big advantage because switching is much more scalable than routing. Routing in itself causes delays, especially when you repeat the signals multiple times. So routing causes latency and throughput loss, whereas we can have a scalable infrastructure through our switch architecture. So basically, you place network nodes wherever Ethernet connectivity is required, and one network can manage many nodes. We also have intelligent network features on this system. First of all, we have self-discovery. So a node can automatically detect another node, so they can connect. So that makes it very easy when you configure a system. Then when it comes to when it's deployed, we also have self-healing and redundancy. So even if there's interference on a link, or if a node goes down, then the traffic is automatically rerouted to use the best path to get to the control center or the offload point. There's also environmental awareness to see, for example, with interference. If there's a lot of interference on a link, then it uses another link as the best path. And it does this in real time, and load balances the traffic as well. So even if you have multiple different sources, different video cameras or other devices that are connected. Each device, as you can see here, can be sent in different directions in the network. So the network always uses the best way to load balance across the entire network, which is also a unique feature. And we can utilize existing fiber points as a part of the network. So we actually say that we don't say we are a replacement for fiber. We say fiber is actually good, cabling is good, and we should use it as much as possible, because that'll mean more redundant points in the system, in the network, that we can use. And the mesh and this wireless network can actually use the cable locations as a link. We don't say that this is a wireless link and the other one is a cabled link. We actually just say that these are links in a larger network, and we can then route and switch our traffic across it, all of it. And this, we have very low latency. It's 1 to 2 milliseconds per hop, which is perfect for video surveillance and other mission critical applications. And we also have negligible throughput degradation per hop. So we can actually sustain the performance over multiple hops. And those of you that know FireTide from before, we can sustain the throughput in a similar way. And we also support traffic prioritization. So you can prioritize video traffic over, for example, VoIP traffic and other different types of traffic. So what is the product then? The hardware product, now I've been talking about more the software side of things, which is really where the uniqueness lies. But we also have quite a lot of good features and uniqueness on our hardware. So this is a Anywhere Networks node. And this is the product setup in an installation. So first of all, I'd like to mention that this is a dual radio node, and most other companies that we've seen on the market only use single radio devices. They do not have dual radio products. The dual radio functionality is very good because we can receive and transmit at the same time. If you just have one radio and you're going to receive and transmit on the same radio, then you lose performance because it's physically impossible. But when you have two radios, we can actually receive and transmit at the same time. And that makes it perfect for repeating the signal. So first you can see that one radio is attached to an antenna, an external antenna at the top. And I should mention that both radios are 5 gigahertz as well here. The other radio is connected to an integrated antenna in this particular node. So we actually have integrated antenna options, and we also have options where both radios are with external antennas. And the integrated antenna goes up to around 1 kilometer in distance with maximum performance. When we have other antennas that we can use to go up to 4 kilometers, 10 kilometers, even over 20 kilometers distance. So it really depends on the antenna. And we have a portfolio of many different types of antennas for all different kinds of scenarios that might be needed. We have a IP67 industrial rated node up between -40 to +65 degrees Celsius, which works in all kinds of environments. We've installed this in Alaska, and from the the snowy regions in Alaska to the very dusty and hot regions in Saudi Arabia. We've installed in these locations for multiple years. So then we also have a PoE output for an IP surveillance camera with the X30 series, and we also have a PoE input, so you can power this node over PoE as well. One of the nice features is that we actually support all network topologies. Other systems, the most common ones tend to be point-to-point and point-to-multipoint that we see. And we can actually start with a point-to-point, upgrade it, and just add more nodes to create a point-to-multipoint. Or we can create a ring architecture or a mesh. And so we actually support all of these topologies depending on what's needed for a customer. And point-to-point solution typically uses 2 directional antennas. So we typically use 20-degree antennas for that, so that we can get longer range and more focused beam. A point-to-multipoint solution tends to use a sector antenna on the central location, and then directional antennas on the subscriber units. Then we also have the ring architecture and the mesh, where we tend to use different types of antennas. A lot of them are mostly directional, but also sector, in case we want to create a full mesh So having multiple different types of topologies gives us a lot of advantages. If you start by looking on the right side here, we see a typical point to multipoint solution, which we see a lot on the market today. And these have some limitations in, number one, that you have a single point of failure at the central location. So if that location goes down, then all the other nodes go down. And it's also difficult to get line of sight with these with point to multipoint solutions. As you can see in this image, because you have buildings in the way, you have trees in the way, or other things. There's you know, you come across so many different things in different deployments, and usually it's difficult to get line of sight to all the locations. And they usually try to find one site which is very, very high up, and it might be difficult to find such a high tower to connect everywhere. So line of sight can become an issue with that. And then you use the sector antennas, and they're wider and they don't reach as far as directional antennas. And since sector antennas are covering a larger area, there's also potential for interference, a larger potential for interference in that particular area. And since you're using one antenna to connect to multiple devices, it's actually also more susceptible to interference, because if you have interference on one channel, then everything's going to be affected. And so this is quite difficult to scale, and it's not possible to customize the frequency depending on each environment for each particular location. So that's why we also then have the mesh topology. So what we can do with that is, first of all, we have no single point of failure, as you can see on the left side. We have a redundancy in the network, so you can actually, even if a link fails or if a node fails, then you can actually, or a pole is, you know, somebody drives into a pole and it falls down, still you'll be up and running with the rest of the network. And it's easier to get line of sight, because all you need to do is to have line of sight to the next location. So you can actually just connect to the neighboring node, which is something you can't do in this way with a point to multipoint. In this way, you can actually, since we use a dual radio architecture, you can actually customize each link depending on each area as well, and this leads to minimal interference. So you can mitigate that as much as possible. And this is also very scalable. You can just keep adding nodes and increase the size of the network as you go. There's also another advantage to the dual radio architecture. So some companies will claim to be able to do, they'll say, oh yeah, we can do the same. We can repeat the signal multiple times. And then what they do is they put a point-to-point device, and then they connect the radio back-to-back to another point-to-point device through a switch. And this is, you can call that a conventional point-to-point chain topology. But the problem there is that you have minimum 2 devices per site versus just 1 device with anywhere networks, and our device is already cost efficient, so it requires almost double the amount of devices, which means that you can save a lot on costs because you're using our technology. And then these conventional point-to-point chains, they also lose, they increase the latency a lot after every hop, because they're not designed to do this. They're originally designed to be just another point-to-point link, not to be a point-to-point chain or a mesh solution or a ring solution. So you see a lot of latency increases, and which is not good for video surveillance. And we can sustain the throughput actually up to 1 gigabit over multiple hops. And it's a much simpler installation as well, because you can just install 1 node with an integrated antenna as well. You just install the external antenna, and then you're ready to go. With the other solution, you actually need to install multiple devices for each one, and that also leads to multiple potential points of failure as well. Yep. So, and then I get asked a lot the question, okay, what about other mesh solutions? What about other Wi-Fi mesh like Cisco, like Aruba, like these guys? And well, my answer is that they're used for access point, as an access point for Wi-Fi, and then they have meshing capabilities on one of the radios. But they are designed to be used for Wi-Fi. which means that they're not scalable at all for video surveillance. So actually, one radio in a traditional Wi-Fi AP is used for 2.4 gigahertz is used for Wi-Fi access, and the other radio is designed so that it supports meshing on the other radio. But since you're using meshing on just one radio and not two radios, you lose 50% of your throughput, because one radio can only talk to another radio at a time. It can't talk to several at the same exact time. So you have throughput loss in the network. And latency increase. So traditional Wi-Fi mesh solutions don't work scalably at all for video surveillance. And many of these companies, they know that already. So actually, we work together with multiple of them, like Ruckus, like and Cisco, and so on. So we've used us as a backhaul, and then hang the access points on our nodes. This is a summary of our main products that we have. We have the X30 series, which is the highest performing series, up to 1000 megabits per second. And this is using AC chipsets. So the X32 is a dual radio node that both radios are 5 gigahertz. One radio has an integrated antenna, and the other radio needs to be connected to an external antenna to point to another neighboring node. And this node has a PoE in and one PoE out. So you can connect the camera to it directly, for example, without needing an external switch. It's IP67 rated. There's surge protection on it. And there's also a programmable RF filter to avoid potential interference, and a built-in heater as well for very harsh cold environments. Then we have another option, which is the X32E, where the E stands for external. And this means basically that both radio have external antennas. So this one does not have any integrated antenna. It's both radios need to be connected to external antennas. And this is used when both sides need to be connected for longer distance, or you need to have a different kind of antenna attached. So the integrated antenna goes up to 1 kilometer. And then if you need longer than that, then there are other external antenna options that we have available to go all the way up to over 20 kilometers. Then we have the X33 series, which is also very similar to X32 because it has an integrated antenna, but it has a third radio that can be used to provide either Wi-Fi or last mile connectivity to another node that needs to be connected. And this is used for smart city, safe city implementations, and where mission critical features are required in networks. And it can also be used as core backhaul to leverage fiber infrastructure. Then we have the X20 series, which is the very cost-efficient series that do up to 600 megabits per second, which is quite a lot still. These nodes are dual radio as well, on 5 gigahertz. One has an integrated antenna. The X20 has an integrated antenna and an external antenna as well. It has one PoE port in, so you can power this over normal PoE. And then you have a IP67 rating on this as well. We also have the X22E, which has an even smaller form factor. And this is the same as the X20, but it has both external antennas instead as well. Then, and then this is then used a lot for more point-to-point. So whenever you need, cost-efficient point-to-point link, this is get two X20s, for example, that's perfect. You can get up to 600 megabits per second of throughput. As I mentioned, we have no license fees on this, and a lot of companies sell, they sell performance fees. Like if you want to have maximum performance, well, then you need to pay this amount. If you want to have maximum features, then you pay this amount, but not with Anywhere Networks. We actually include all of this. So we made it very transparent and simple. So the X20 series can also be used then to connect a smaller number of devices for more smaller deployments, whereas we recommend the X30 series for larger, higher scale deployments. This is the Anywhere Node Manager, which is used to manage all the devices, all the nodes, and it can be used for staging, for configuration, for troubleshooting, for alarms, and so on. You auto discover nodes in this network, and it's mainly used for the configuration. So this does not need to be an active This does not need to be continuously running somewhere on a server or like a controller. Actually, all the nodes are completely independent of it. So you can install the Anywhere Node Manager on your laptop, and you connect to the network, you configure it, and then you can close the laptop and walk away. Everything is working as before. So there's no like single point of failure in some kind of controller or something like that. And through it, you get a topology overview of the network. It has a very intuitive design, so it's easy to use, which is something we've learned from past experience. So after starting Firetide, we saw how we could even improve and make a much user-friendly, a very user-friendly interface. You can also see statistics through the RSSI viewer, and you can see the RSSI, and you can also then align antennas. So there's an antenna alignment feature, and yeah, it can perform all the operations here. In summary, I know I've talked quite a lot now about a few different network features that we provide, the dual radio architecture, and I wanted to summarize some of our key advantages here. So one of the main things is that we're a very scalable solution. There's other wireless solutions are more limited in their scalability. You make a point-to-point solution and point-to-multipoint solution there, but then if you want to actually scale this to build a city-wide infrastructure, connect multiple locations, they're just not scalable. And we have a smart distributed switch functionality that really allows us to have a very high performance on the network, and allows us to repeat the signal multiple times across the network without losing any performance. And we scale up from small deployments up to 19,200 nodes without sacrificing any of this performance. And we have a total network capacity of over 1,000 gigabytes. So this is a lot. So over 1,000 gigabits. It's a very intelligent network. There's many features like load balancing, automatic failover, redundancy, self-discovery, and we'll be adding many more intelligent features to make the network even more intelligent. It's very flexible, as we can support any kind of deployment topology, which makes it very suitable for all different kinds of application areas. We have a dual radio architecture, which also helps with the scalability aspect, and we have an integrated and external antenna options available. We have a security aspect as well, where we have wireless AS encryption on the entire network, plus encapsulation, as well as MAC address filtering, mesh ID clusters, or network ID clusters that are then specific for the network to enhance the security even more. It's very cost efficient as well, and it has no license fees, as I've mentioned. These are our key flagship customers, such as MTR, Chubb, Telestra in Australia. We have a Chunghwa Telecom operator in Taiwan, which we're doing a smart pole implementation project, a citywide project in Taiwan that I'll talk a little bit more about. We're working with Siemens, as you might be aware, on airports in Alaska. We've deployed already 2 airports, and we'll deploy many more together with them. And we've deployed for multiple other customers and various different police departments around the world. Now I want to get into a little bit more of on the market side, and to see some sample applications and success stories. So we primarily target, as I mentioned, safe city projects where video surveillance is required, because it's really the most difficult thing to do over wireless. You require to have very low latency and very high throughput. And so, as Bo mentioned, it can be used for prisons, public security, municipality control, and events monitoring, setting up temporary events, and construction sites as well has been actually quite a interesting application area. Industrial connectivity for industrial applications, such as plants and warehouses, real estate. Many industrial refineries has been quite a big one as well, and utilities companies. And then for transportation system to connect railways, terminals and airports, ports, as well as then smart city implementations that I mentioned before. There are a host of other applications, but these are the ones we've mainly focused on. So a little bit more about the project with Siemens. The application is access control in this case at multiple airports across the US. And we're using the X32 product. There's coverage required here for up to 20 locations approximately at each airport for access control. And there's not a line of sight available at each location. So you need to have repetition. To get line of sight, you need to have repeaters. And so our solution works perfectly for that. And the cabling and trenching was not an option in this case, so you really need a wireless solution. And we deployed a hybrid topology, or Siemens deployed a hybrid topology of daisy chains and mesh rings, 20 units approximately at each airport. And we have 2 airports that have been installed so far in Alaska, and we have 20 more airports that are planned, among others in Hawaii. One of the key features here was the rapid and easy deployment. The fact that it's a highly secure network with a very flexible future expansion, and then that it's very resilient and self-healing, because this is a critical application for the airport. We also did a deployment in Sweden, my home country. We did a deployment here. I just wanted to share this because it's just interesting how quickly and how easily you can actually deploy a network. And in this case, our customer had very, very limited time for deployment, and there was no clear line of sight from the control room to these locations. And they needed to have 5 different locations connected with cameras. And we designed a solution. We used the X20s in this case because it's just a few locations, we provided up to 400 actually megabits of throughput on this project, and with over 6 cameras. So they could have added much more cameras than this. There's a very, very high capacity on this network. And they actually, in the morning, we did a walkthrough with them online. The integrator, they learned how to configure and everything in the morning around 8 a.m. and they were deploying by lunchtime, and they were done in the afternoon, from just learning how to configure it to actually full deployment and up and running in less than 12 hours. So if that's not quick, then I don't know what is. Then we have another project example I wanted to take here is a project in Australia. And this is actually a FireTide project from the beginning. It was originally designed based on FireTide, but then FireTide could not supply the equipment. And so Anywhere Networks was asked to provide a solution. And actually, they could actually increase the amount of cameras several times because the throughput provided in this network is much higher than it was in FireTide's. So actually, they increased from 50 cameras to over 100 cameras in the whole deployment. And we deployed 2 rings, as you can see here, with the X20 product. The yellow is the existing fiber that was available, and then we had wireless links. As you can see here, it says P2 Wireless, which was then our previous name. We rebranded to become Anywhere Networks. And we use a dual ring configuration, and you can also see that there's a hardware redundancy because there's multiple fiber offload points, and so even if one of the nodes fails, then the traffic is rerouted in the system. And this is deployed in less than 2 months, and they also connected IP speakers for public announcements to the network. We're also doing a smart lamp pole project, and this is very, very interesting because it's something that's coming up more and more. We're seeing this as a trend because there's lamp poles in all cities, millions and millions of lamp poles, and these are close together. They already have electricity. What they're missing is network connectivity, and it's becoming more interesting to hang different kinds of sensors, the displays, like our partner in Taiwan has been doing here. They used sensors to check how the air quality is in the city. They used IP cameras and had analytics on those for people counting and facial recognition and so on. They have digital signage so that they can have advertisement. They can add Wi-Fi access points and many more. And the smart thing that they wanted to do here is also use it for in the future to deploy 5G, to use this as site acquisition, because with 5G you'll need a lot more small cells being deployed, at least 10 times the amount of equipment from 4G. So they're actually deploying these smart lamp poles and putting our nodes on them for providing the network connectivity. They're also replacing with these LED lights. They're actually able to customize the color of the lights, and they require much less electricity. So actually the whole installation is paying for itself by the savings of electricity within 4 years. It's actually paying for itself, including all the equipment and so on. And the first network was deployed with 54 units of X20s, and they're going to be doing a total of 600 units in this city, and then they'll move on to more cities. We're seeing that this is becoming a more and more interesting application, and our network is really perfect for it. You just put a node on these lamp poles, and then these lamp poles will then mesh together and connect together with all the other ones. And since they're close by, it's a very easy link to do. And then if there's any existing cabled infrastructure, you just connect it and offload the network. So it's a really interesting application that we'll probably see more of. And with that, I would like to thank you for listening. I've been talking now for a little while, and I'm going to open up for questions. Okay, so we got the first question. Do you have a configuration software at the location or remotely? Is there a way to tell what went up and down remotely on the system? Well, our configuration software is installed on a server or laptop at the location, and so it needs to be connected to the network so that you can monitor it. But with that being said, it's a standalone system, so the nodes, they work standalone. But if you want to be able to monitor the system at all times, then you need to be connected to it at all times. But you can actually set up a VPN tunnel to a server, for example. So if you have a server at the installation site where you've installed the software that's running, then you can set up a VPN tunnel so you can remotely always log into the server, and that way you can always monitor whatever's going up and down and receive alarms and so on. And we have another question. What are your training options, and what is the cost for the training? Is that a part of the bill of materials? Well, since the configuration is quite simple and straightforward on our products, we've decided that it's really enough to do an online training with us, which takes around 2 hours approximately, depending on. With FireTide, we used to do certification training that took several days, but we've decided to step away from that, and we've really made this configuration tool and technology much simpler and easier to deploy. So we don't see that we really need to have such an extensive training course, and it's been enough for many integrators to work with this online training course, and we're providing this free of charge at the moment. If a customer needs any more specific training, then we can look on that more detailed on a case-by-case basis. We can, if there's a bigger project where you need some specific training for the customer or deployment, then we can, where you need training on site, then we can look at doing that on a case-by-case basis. Okay, so the next question is about the controller, about a controller. So for the controller itself, is it connecting to radios by a client, like you do with MikroTik, or is there also a web terminal UI, like with Siklu or Trango? Well, actually, our system doesn't use a controller. So the nodes, they operate completely independently. So even if you configure everything using your laptop and then shut down the laptop and walk away, the nodes and everything is still working independently. So our management software is actually more of a configuration and monitoring tool. It's not really a controller, which also means that we have no single point of failure, which you would have in a typical controller, because if the controller would be affected, then the network would be affected. And this management software is not available via the web, direct to the devices. So it's a Windows-based configuration software that you install on the server or laptop. And yeah, regarding control, we're actually working on a cloud-based controller that you will, where you will be able to log in from anywhere. And so we'll be coming with that in the future. That's not there at this point. Oops. Sorry about that. Then we also have another question here. Question about statistics running live. I know you can save the configurations, but can you go back, look at, and save the history of the system performance over a period of time? So this feature is currently not possible, but it's something that we're working on, and that will come later this year as we launch a controller feature. So that will be coming. It's a good question. And then we have another question here. Do you support 802.11x? Well, 802.11x, that's a Wi-Fi standard that we are using on our network, since we're utilizing the Wi-Fi based 802.11 protocols for operation between our nodes. But at the same time, it should be noted that our communication protocol and routing protocol is proprietary. So a general Wi-Fi client device will not be able to connect wirelessly to our nodes. If you want, that's because our nodes are using a proprietary protocol that's not the same as a normal Wi-Fi client protocol. So if you actually need to connect a Wi-Fi client device, like a phone, a smartphone, or a laptop or tablet, then this Wi-Fi client would need to connect to an access point that then is connected to our network via an Ethernet cable. So you'd actually need to connect a Wi-Fi access point, which is meant for Wi-Fi and not for backhaul. So if you connect a Wi-Fi access point to our network via an Ethernet cable, then you'll be able to connect through the Wi-Fi access point to a client device. I hope that answered most of your questions. Yeah. Doesn't look like we have any more.
Marcus, thank you so much for addressing all these questions. Just before we close, I would like to thank everybody for attending our webinar today, and to say a couple words about Anywhere Networks and our engineers. As you know, we provide a reliable data transport for public safety, video surveillance, and multiple other IoT connectivity projects, and definitely are looking into the future as our engineering team is constantly working on improving our hardware and software. We will be updating you on our newest developments very, very soon. So please contact us with any questions you might have, and we'll be happy to address each and every one of them. So have a wonderful day, and thank you very much.